All right, in this video, we're going to talk about activity 3, the tree growth problem. So Noah's growing 3 different types of trees. He's keeping track of the heights of each tree over time. But for some reason, Noah tracked this in 3 different ways. The first one, he has an equation for the first tree over m months. The second one, and this is measured in feet, so at least he's measuring it in feet. So don't get confused and say that this is 3.5 meters. This is m months. So this is the number of months. This is the height in feet, which we'll get to in a second. The second one he collected in a table, and in the table he's got the time and month and the height of the tree. And the third one shows the graph with the time and month and the height in the tree. So which tree is the slowest growing and how do you know? Well, I'm going to do this first. I'm going to call this one purple, I'm going to call this one blue, and I'm going to call this one green. So all 3 of these things represent different trees in different ways. And what we should recognize here is that every time that we have in some kind of equation or some kind of table or some type of graph or any kind of equation even, any equation can be represented in 3 different ways. Any equation or any model can be represented in 3 different ways. And those 3 different ways are, as you might imagine, an equation, a table, and a graph. So what's basically happening here is we've got Noah showing us three different trees in the 3 different ways that we can possibly show any model or any situation. Maybe we can even just say mathematical situation. Maybe that's a better way to say any mathematical situation. So any mathematical situation can be modeled in or represented in these 3 ways. So if we want to compare these things, really what we need to do is we need to get them all to the same form. So we can either create 3 different equations, we could create 3 different tables to see which one's going, or we could graph all 3 of them onto the same graph. And, just because I've got the means to do the graphing, I think I'm going to do the graph first, because here we've got a nice line. We can even see the slope of this for every 1 month. For every 1 month that we go over, it looks like we're growing 2 feet. So we're going for every 1 month, we're going 2 feet because the scale is going by 2. And here, this isn't in 1 month at a time, but I could drop in some things in here. So let's go with an equation. So first off, let's make this our green line, since we have our green line there. So there's our green line, and we've got our 3 points here that are already noted for us. So now I'm going to choose my equation. So in the previous examples, we know that we have our general equation is y and what we found is with our y, we can use this same equation over here. Even though we don't have y and x, we can use h and m, because that's our y-axis and our x-axis. So our height, here's our height, h, here's our time and months, m. So we've got our h-axis and our m-axis. So if we've got an equation h equals 3.5 m, that's really saying the same thing as 3.5 m plus 0. So we've got no y-intercept. So that means it's going to start down here at the origin. And we're going up 3.5 for every 1 month, we're going up 3.5 meters. And I know that because if I do what is the height when m is 1, I've got 3.5 times 1, which is 3.5 meters. What is the height when m is 2? Well, I'm basically creating a table here, right? So that's going to be 7 feet, not meters, 7 feet. What is the height when we've got 3.5 times 3? Let's see, so that's going to be 10.5. So I've a table for this, and so let me put that over here. If this is our time in months, and this is our height in feet, I've just created a purple table where I got 0, 0. So at no time, no months have passed, the height is 0. When it's 1 month has passed, we've got 3.5 feet. When 2 months have passed, we've got 7 feet. When 3 months have passed, I've got 10.5 feet. So I can actually graph this right now. So there's 0. When it's 1 month, we're at 3.5. So that's going to be somewhere right about in there. Right about in there. Not quite half, or a little bit more than half, because 3 would be halfway. When it's 2, it's at 7, so that's going to be right there in the middle. And now I can start graphing this line here. That's kind of about right. So I can already see that this one is steeper. So at 2 months, this green one has grown 4 feet. At 2 months, this purple one has grown 7. So it already looks like this one is going to be growing faster than this one. So let's figure out where this blue one falls in. So if I go with the blue one, now I can, again, just graph these values on here, and I can compare the steepness of the slopes, or the steepness of the lines. So at 2 months, we go 5 feet. So at 2 months, we're going to go up to 5 feet. So we're going to be right there in the middle. So 2 is 5. And then at 4 months, we're at 10 feet. So at 4 months, we're at 10 feet. So that's going to be about right there. And so I can connect those and connect those points. And I'm also going to go from here, and I'm going to try and connect those lines. Now wait, how did I know that this was going to go through 0, 0? Well, let's check. As I go from here to here, I have gone down 5. And here I've gone down 2. So if I went down 2 more, minus 2 again to get to 0 months, I would have to go down 2, or go down 5. So I have to go down the same amount. For everything that I go down here, I have to go down the same amount. So if I go down 2 units here, and I go down 5 here, if I go down 2 more units, then I have to go down 5. Here it's kind of tricky, because here it's going down 1 unit. So if I went down, sorry, that's going to be 0 there. So here, if I went down 1 unit, I can see that I'm going down 2.5. I'm going down 2.5 feet. So here, if I look over at this graph, if I'm going from 1, which is about right here, 1 month, as I go up 1 month, I'm going to go up 2.5. So this looks like it's kind of right in the middle here. So that might be at 3. So if I'm at 3, there's 4. And then, is that 3? Well, it might be even a little bit less than 3. It might be a little bit lower than 3. So maybe that's that 0.5. So here it's kind of tricky to gauge on that, but we do want to make sure that we're keeping track of this. But if I do see, if that's going down 1 and that's going down 2.5, obviously that matches the same rate. If I were to jump 2, then this is doubled. So if this is doubled, this is doubled. So I know I'm kind of going in the same spot here. So which one is growing slowest? Well, the slowest, the most shallow slope is the green line. So the green graph is the one that is going to be growing the slowest. The purple is growing the fastest, and the blue is growing the slowest. Now you could also do it by comparing the slopes for each one. Here we've got a slope of 3.5 for the purple, and for the blue, well, look at this. Here we go. For every x, or for every m, we go down 2.5, or if we look at that, we can say our slope Let's not use m because m is months. So our slope for the blue line is for every time we go up here, every time we go up in this way. So now I'm going back this way. I'm going this way. So that way is positive 1. So as I'm going up 1, I'm going to be going up 2.5. So my rise, my rise, my height is 2.5. My slope, or my run, sorry, my x, my m, my months is positive 1. And you're saying, well, wait a minute now, why did I pick the positives ones? Well, I could have done this way as well. I could have gone and said, well, what if I'm going this way? What if I'm going down? That would be like me saying, okay, I'm going to go down this way. I'm going to go my rising this way and I'm running this way. So I'm going down in a negative direction and I'm going over in a negative direction. And so then I just have negative 2.5 over negative 1, which of course, negative 2.5 over a negative 1, well, a negative divided by a negative is a positive, so we still end up with 2.5 for our slope. So right there, we can also see that this one is steeper than this one. So, okay, that's in the middle. Now, how do we find the slope of this one? Well, we can do our slope equation. And if you don't remember, our slope equation, the slope equation is y2 minus y1 over x2 minus x1. And this means you take one of your points. So let's call, actually, I'm going to move this over a little bit so I've got some more space to work. Let's call this point 1 and this point 2. You could do it the other way around too. So if I've got point 1 being 4, 8 and point 2 being 5, 10, well, that means this is x1 and this is y1. This is x2, this is y2. So now I just need to drop these things into this equation. So our slope here now is 10 minus 8 is 2, 5 minus 4 is 1, so I've got a slope of 2. So if I go back and look here, our green line, the slope is 2. So, okay, so now again, let's compare. If we've got a slope of 2, we've got a slope of 2.5, and a slope of 3.5. Well, which one's growing the slowest? Again, that kind of reiterates this green one is the lowest number, so it's going the slowest. Hope that helps.